In this video, we're going to look at how we can use arrays to process loops. Processing loops with arrays is where we get tremendous power from languages, particularly languages like C. Remember, computers excel at doing the same set of operations again and again, and that's what loops do. And when we're processing large numbers of numbers, then arrays are a good place to store these. And when combined with loops, having a loop change the subscript makes it very easy to walk through an array and process it. So in this example, what we're going to do is we're going to read a bunch of floating point temperatures until somebody enters minus 99. If it ever hits minus 99, we probably won't be worried about a program to calculate the temperatures. It's going to calculate the average of the temperatures, and then it's going to print out all of the temperatures that are below the average. So those are really cold days, below average days, and we want to know what they are. We start up here and we define a constant, max nums, and that's going to be the maximum number of temperatures that we can hold. And our array has the ability to hold up to 100 temperatures, but we may not use them all. So we declare our array, we call it temps for temperatures, and its size is max nums. So because that's defined as a macro, it'll fit 100 in there. Where it says max nums, it'll be replaced by 100. I've got other variables. I've got a sum, which is going to hold the sum. I've got the average when we calculate the average. N is a number I'm going to read in, and I'm storing it in a regular number before I enter it in the array, and it'll become obvious why. I've got I, which is going to be a loop counter. N temps is going to be the number of temperatures we've read. I initialize it to be 0. Keep going is a flag variable that I'm going to be using to control my loop. So it would be interesting to see how I use a flag variable here to make sure that the loop does what I want and exits when I want. Let's start to look at the basic loop. It's a do while loop, and it says enter a temperature, minus 99 to stop. It does a scanf with %lf, which of course is the code for a long float, which is another word for double. $n is where it's going to store it. And we always have to have our ampersand in front of that. And it says if n is not equal to minus 99, then it's a number we want to store into the array. We also want to sum it up. So I say sum plus equals n, which is a shorthand, you might remember, which is equivalent to saying that sum equals sum plus n. Then I store it in the array by saying temps sub n temps plus plus equals n. Now that's kind of two statements in one. This is a post increment of the counter of how many temperatures we've read. When we come into this loop for the very first time, we've read 0 temperatures. This is going to say temps sub 0 and store n into it. Then it's going to add 1 because it adds 1 after the number n temps has been used. So after it subscripts a 0, it's going to add 1 onto it and make it 1 because I have now read 1 temperature. The second time through the loop it's going to come in, it's going to store it in temps sub 1, and then it's going to increment that in temps to make it 2, indicating that I've read 2 numbers. And it actually works out perfectly because it gets the right subscript, and after it does the increment on it, it actually has the right number that I've read. So after it comes through here, it always has the correct number of values that I've read. Now, if a number happens to be minus 99, I go down here to the else, and I set keep going to be 0. Keep going started at 1 up there. So it's going to stay 1 until I set it to be 0. And I do my loop while keep going. Now, a lot of you are probably confused and you're saying, well, why doesn't he say keep going equals 1? Well, I could say that, but it actually means exactly the same thing. And as you get more used to working with Boolean values, you won't bother to say the equals 1. But if you feel more comfortable with it at this stage, go ahead and do it. Okay, at the end of that loop, it's going to kick out. It stored all the values in the array. It summed them up, and now we're ready to calculate the average. So the average is simply the sum divided by the number of temperatures I read, and then I can print out my average is %D for the number of temperatures, and %.2 LF is the code for printing out the average temperature. Now that 0.2 means I want 2 places past the decimal, and it is going to round the result to some temperature, a period for the decimal point, and then 2 places after the decimal. Okay, so after I print out what the average is, I have to now go through my loop, which is going to process the array, compare every member of that array to the average, and if the temperature sub I is less than average, I'm going to print out it's below average. Okay, so it's very simple. The for loop starts I out at 0 and it stops at n temps minus 1. This is where the math all works out perfectly, because it starts out at 0, which is what a subscript starts out at, and it stops at n temps minus 1. Well, if there were 5 temperatures, n temps minus 1 would be 4, and the value of I would go 0 the first time through the loop, 1 the second time, 2, 3, 4, and then stop. And of course, 0, 1, 2, 3, 4 is the subscripts for an array with 5 members in it. So it generates exactly the subscripts we want. And that's very important. So for every one of those temperatures, temperature sub I, where I is going to be different every time through the loop, we check to see if it's less than the average. If it is, we print that out. If it's not, we do nothing. Then at the end, when we exit that loop, we return 0. Some people might be worried, well, what if we don't have a full 100 temperatures? What happens to the rest of the array? It's empty. It's not really empty. It's memory that we haven't put any values in. It has some values in it. We have no idea what they are, and we don't care because we're not using them. And others might be saying, well, you're wasting memory. If you've got less than 100, you're wasting memory. That's true, but when you take the next course, they'll show you much better ways of manipulating memory so that you won't waste memory like this. So right now, you're just getting started. Don't worry about it. So this is how we use loops to go through and do fundamental processing on arrays. And this is a very common way to program. So that's it, all about arrays and processing with loops.